Hello, good evening, students. Good evening. Give me the clearance, audibility, visibility बताइएगा please. Good evening. Yes, give me the clearance. Am I audible and visible? Pawan Kumar, Siddhi Rathod. क्या क्लियर हूं? Audibility, visibility clear है? All clear, very good. So very good evening to all of you GATE aspirants. Welcome to Unacademy platform. Dr. Khalil Khan here, welcoming you to operating system course नया आगाज सीरीज. और आज का हमारा टॉपिक रहेगा थ्रेड्स एंड मल्टी थ्रेडिंग. पिछले क्लासेस में हमने देखा था प्रोसेस कॉन्सेप्ट्स, राइट? या थैंक यू सो मच. तो many students were asking for restarting the series again, क्योंकि हमने 4-5 लेक्चर्स लेकर कुछ ब्रेक दिया था, because number of students were not regular. तो मैंने सोचा कि ठीक है, if you require the series then we will go for it. Then again based on the demand, मैंने सोचा ठीक है, we will try to at least conduct few more sessions. ठीक है, तो बच्चों आज का सेशन होगा थ्रेड्स एंड मल्टी थ्रेडिंग. काफी इंपॉर्टेंट टॉपिक है. अगर आप गौर करो तो मैं पूरा एक लेक्चर, ये पूरे लेक्चर्स इन सीक्वेंस में कवर कर रहा हूं. फर्स्ट आई हैव अ कपल ऑफ सेशंस ऑन इंट्रोडक्शन एंड बैकग्राउंड. फिर उसके बाद हमने प्रोसेस कॉन्सेप्ट देखा, दो कपल ऑफ सेशंस, जहां पर हमने देखा डिफरेंस बिटवीन प्रोग्राम एंड प्रोसेस, प्रोसेस एज एन एब्स्ट्रैक्ट डेटा टाइप. फिर उसके बाद द प्रोसेस स्टेट ट्रांजिशन डायग्राम, क्यूइंग डायग्राम, टाइप्स ऑफ क्यूज मेंटेन्ड बाय ऑपरेटिंग सिस्टम, and then schedulers and dispatcher. अब उसके बाद before we start CPU scheduling, one of the important topic that we need to discuss जो है threads and multi-threading. इसके बाद हम CPU scheduling start करेंगे. ठीक है, तो काफी क्वेश्चंस प्रीवियस ईयर में आ चुके हैं विथ रिगार्ड टू थ्रेड्स एंड मल्टी-थ्रेडिंग. तो हमारा एजेंडा होगा टू सी व्हाट इज अ थ्रेड, डिफाइन थ्रेड, कंपेयर थ्रेड एंड प्रोसेस, and then see the benefits of threads, and then essentially types of threads, then thread models. These are the issues that we are going to discuss in this chapter. हाँ, अगर टाइम मिला है लेक्चर में, then I will also have a discussion on fork system call. क्यों डिस्कस करेंगे हम fork system call, वो भी मैं आपको शेयर करूंगा. तो सबसे पहले हम डिफाइन करेंगे what is a thread, right? So before I come to these points which I have got, यहां पर हम लिखेंगे फॉर एग्जाम्पल. सो लेट मी जस्ट मेक ए स्मॉल सेटअप. ठीक है, ऑलराइट. सो लेट अस राइट थ्रेड्स एंड मल्टी थ्रेडिंग. So as far as GATE exam is concerned, and also the general concepts of operating system is concerned, primarily ये एक important topic है, क्योंकि मॉडर्न डे जो एप्लीकेशंस है, क्लाइंट सर्वर एप्लीकेशंस होने दीजिएगा या फिर इंडिपेंडेंट एप्लीकेशन, स्टैंड अलोन एप्लीकेशंस होने दीजिएगा, we basically have threads as an important issue. Many of the applications are multi-threaded. पहले आप बताइएगा बच्चों, फ्रॉम योर नॉलेज, व्हाटएवर आपने पढ़ा होगा कि What is a thread according to you? आपने जहां से भी पढ़ा होगा, कोई टेक्स्ट बुक से शायद, या इंटरनेट रिसोर्स, या व्हाटएवर रिसोर्स जहां से आपने पढ़ा होगा, कैन यू टेल मी व्हाट इज द स्टैंडर्ड डेफिनेशन ऑफ थ्रेड? जैसे वी हैव अ स्टैंडर्ड डेफिनेशन ऑफ ऑपरेटिंग सिस्टम, इंटरमीडिएट बिटवीन यूजर एंड हार्डवेयर, इंटरफेस बिटवीन यूजर एंड हार्डवेयर. उसी तरह प्रोसेस का एक स्टैंडर्ड डेफिनेशन है, प्रोग्राम अंडर एग्जीक्यूशन. प्रोग्राम अंडर एग्जीक्यूशन इज द स्टैंडर्ड डेफिनेशन ऑफ प्रोसेस. इंस्टेंस ऑफ ए प्रोग्राम हमने कहा था. उसी तरह थ्रेड का भी एक स्टैंडर्ड डेफिनेशन है इन एनी टेक्स्ट बुक ऑफ ऑपरेटिंग सिस्टम. जनरली वो क्या है डेफिनेशन? डू यू नो व्हाट इज द स्टैंडर्ड डेफिनेशन ऑफ, पॉपुलर स्टैंडर्ड डेफिनेशन ऑफ थ्रेड? एनी आइडिया, एनीबॉडी? राजा बाबू, शीला कुमारी, पवन कुमार, so many people are there. क्या आपको पता है what is the standard definition of thread? Any idea whatsoever? Come on, boys and girls. Please respond. The popular common definition, let us write it here, is a lightweight process, or let me write it fully. Thread is a lightweight process. Yes, Ranjit also said correctly. Thread is a lightweight process. इस definition से हम पहले ये understand करने की कोशिश करेंगे. There are two things that we need to understand in this definition. Number one, why thread is known as lightweight? This is the first thing that we need to understand. Why is it lightweight? And moreover, आपने ये understand करना है कि thread is also a process. देखिएगा, thread is also a process. मतलब whatever we studied with regard to process equally apply to thread. जो भी हम process के लिए पढ़े हैं equally applies to thread, because thread like is also a process. So essentially like a process हम बोल सकते हैं, essentially like a process we can say that like a process, we will write like this, like a process, thread is an active entity, and like a process is a schedulable unit, and like a process is a unit of CPU utilization, is unit of CPU utilization. Unit of CPU utilization का मतलब ये है कि a unit which can run on CPU, a unit which can execute instructions on the CPU. CPU पर execute होने के दो units है, एक है process, दूसरा है thread. There is no other thing. Maybe एक distributed system में एक और entity है, we don't want to go into it. As far as a one-level architecture is concerned, a unicore or multi-core processor is concerned, unit of core utilization, unit of CPU utilization is a thread or a process. Yeah, good evening again to all those people who came late and wishing on the chat box. Good evening. I hope you are doing well and your preparation is also going on well. चलिए, तो बच्चों यहाँ पर अब हम फिर से एक बार रिव्यू करेंगे कि प्रोसेस के बारे में जो हमने पढ़ा था, ताकि हम अंडरस्टैंड कर सकें व्हाट एग्जैक्टली इज थ्रेड, व्हाट एग्जैक्टली इज प्रोसेस, हाउ आर दे सिमिलर एंड हाउ दे आर डिसिमिलर, डिफरेंस बिटवीन प्रोसेस एंड थ्रेड. So if you remember and recollect, we have earlier occasion defined process as what? What is a process structure? So that we can build up understanding for thread. Process as a data structure, process as an abstract data type. If you remember, process as an abstract data type. If you remember, we said process as an abstract data type. We said that we'll have the following components. What are the components? Let us analyze. Process, you can put code section here or top, that does not matter. So maybe I am comfortable drawing in this way, code or text section. This may be high memory, this may be low memory, that is not concerned. This is called the code or text section. Then the process will have the data section, initialized and uninitialized data. Then the process will have something called the heap, which can grow and shrink. And then finally the process will be associated with a runtime stack. So boys and girls, if you remember, ये हमने कहा था the regular process structure. This is a regular process structure having important components: code and text section, data section, heap section, and runtime stack. Okay? So what does code and text section contain? The code and text section contain, if you remember, the instructions of the process or instructions of the program. This is generally the global variables, and particularly those variables which are allocated with static storage class in the language like C++. And these the heap from where we allocate space using dynamic memory allocation, using functions like in C malloc या फिर new operator in C++. Runtime stack can also grow and shrink, और इसका जो objective है runtime stack का will be meant for storing activation records of function calls. जो भी functions आप call करोगे उनके activation records यहां पर stack में आप store करोगे. तो boys and girls, this was a review with regard to the process structure जो हमने study किया था in earlier chapter. Because ये फिर से हम क्यों रिव्यू कर रहे हैं, क्योंकि थ्रेड का जो आर्किटेक्चर है, थ्रेड का जो स्ट्रक्चर है, बेसिकली वुड कम आउट फ्रॉम दिस. सो दिस रेगुलर प्रोसेस स्ट्रक्चर. हाँ, एक बात यहां पर मुझे ये कहना है कि ये जो सेक्शंस है, कोड, डेटा, हीप, प्लस इट मे हैव अदर रिसोर्सेस, प्लस सम अदर रिसोर्सेस लाइक फाइल्स होंगे या आईपीसी मैकेनिज्म्स होंगे या सिंक्रोनाइजेशन मैकेनिज्म्स होंगे एज रिसोर्सेस. This will be called in as another term in the literature, generally called address space. These called the address space of the process. Memory में जो store होगा, code section, data section, heap section, plus other resources like files हो सकते हैं, and then pipes हो सकता है, other IPC mechanisms, all that constitute what is called address space of the process. हर process का अपना own address space होगा. Then runtime, every process will be associated with a runtime stack in the user space. जहां पर यूजर डिफाइंड और प्री डिफाइंड फंक्शन कॉल्स के एक्टिवेशन रिकॉर्ड्स पुश होंगे. व्हाट डज एक्टिवेशन रिकॉर्ड कंटेन? इट कंटेन लोकल वेरिएबल्स, फॉर्मल पैरामीटर्स एंड पर्टिकुलरली द रिटर्न एड्रेस. वो होगा एक्टिवेशन रिकॉर्ड्स. हमने एक एग्जांपल भी देखा था, राइट? सो अब यहां पर हमें जो देखना है कि बाय डिफॉल्ट, लेट मी राइट एज अ स्टेटमेंट फॉर यू. बाय डिफॉल्ट, ये काफी ज्यादा इंपॉर्टेंट पॉइंट है. बाय डिफॉल्ट दी ट्रेडिशनल प्रोसेस, ये हमारा ट्रेडिशनल प्रोसेस है जिसे हम बोलेंगे इन आवर टर्मिनोलॉजी हेवी वेट प्रोसेस. बाय डिफॉल्ट द ट्रेडिशनल और हेवी वेट प्रोसेस जो हम यहां पर देखे हैं, राइट? ट्रेडिशनल प्रोसेस इज हैविंग a single thread of control, इसीलिए हम ये प्रोसेस को भी बोलेंगे सिंगल थ्रेडेड प्रोसेस. ट्रेडिशनल हेवीवेट प्रोसेस, कन्वेंशनल प्रोसेस जो हमने पढ़ा अब तक, जो हमने देखा, दैट इज जनरली आल्सो कॉल्ड सिंगल थ्रेडेड प्रोसेस. बाय डिफॉल्ट कहना ये चाह रहा हूं कि जो ट्रेडिशनल प्रोसेस कॉन्सेप्ट हमने जो देखा है अब तक, that is also having a thread. So invariably ये कहना चाह रहा हूं, thread as such is altogether not a new concept. ट्रेडिशनल प्रोसेस में भी थ्रेड का कॉन्सेप्ट है, बट इनफैक्ट हम बोलेंगे सिंगल थ्रेडेड. अब हमें अंडरस्टैंड ये करना है कि व्हाट डज दिस थ्रेड इंडिकेट. दैट इज वेरी इंपॉर्टेंट. व्हाट डज दिस थ्रेड इंडिकेट? द थ्रेड इन द ट्रेडिशनल प्रोसेस, व्हाट डज इट इंडिकेट एंड हाउ इज इट डेजिग्नेटेड? दैट वी हैव टू अंडरस्टैंड. तो आई विल ट्राई टू एक्सप्लेन इट बाय मींस ऑफ ए डायग्राम. फिर उसके बाद मैं ये पॉइंट्स पर आऊंगा. ये देखिएगा प्लीज. I will advise you to have a close look at this, please. I'm highlighting this as single-threaded process. Let me put a what do you say, marker for this single-threaded process. Look at the structure, boys and girls. जो structure हमने पहले देखा था वही यहां पर है. देखिएगा, वही है यहां पर single-threaded process. If you look at the components of the structure, closely. I have code section, I have data section, I have resources like files, plus there are some attribute information like registers, program counter and stack. So boys and girls, this is what is generally called the address space of the process. Address space of the process. जो regular structure है plus some attribute, some environment information, right? Environment information. Code, data, static data, static data, dynamic data, files. यहां पर heap भी आएगी. If you want, let me write. Heap is also part of this. That's what I'm saying. Static data, dynamic data. Data एक ही लिखे हम. So it includes heap. Registers, general purpose registers, program counter. What does program counter contain? Can anybody please write down in the chat box so that I know whether you are understanding or not, you are following or not. What do registers contain? Or what does program counter contain? What is the relevance of this program counter and the code section here? Come on, boys and girls. What is the relevance of program counter and the code section in the process structure? What does program counter contain in relevance to? In relevance to the code section of the process structure. Anybody? बोलिए. Come on, come on. Text startup. Yes. Next instruction मतलब क्या? Program counter will not contain next instruction. No, Shiva Kumari is correct. Address of next instruction. Address of next instruction to be executed in the code section. Program counter will contain general registers value will store values of the temporary results of the previous incomplete operation or some values of the temporary operands, temporary results program. और ये stack जो अभी हमने कहा runtime stack meant for storing the activation records, ये सभी मिला के हम बोलेंगे ये है address space of the process. By default, every traditional, this is my single threaded process or traditional heavyweight process, heavyweight or traditional process का जो structure है, by default traditional, by default this traditional or heavyweight process is having thread of control, line of execution, thread of control. अब मुझे आपसे ये पूछना है, let me see how many of you are knowledgeable या how many of you are familiar. How many of you are familiar with this? Can anybody tell me? So I'm saying that the traditional heavyweight process is also having a thread. Look at this. Is also having a thread, which is indicated like this. So boys and girls, there are two questions which I want to ask, and let me see how many of you will try to respond to my question. Question is, listen. Ye thread, why this thread is, what does this line indicate first? What does this line indicate? And secondly, why is that line a curvy line? Curvy line. Why not it is a straight line? What does the thread as a line indicate? First question. And why that line is a curvy line? Why not it is a straight line? वो straight line क्यों नहीं है? वो curvy line क्यों है? And moreover, what does that line indicate? That's a very interesting question. Because generally आपने भी पढ़ा होगा कि thread is indicated like this, single threaded process. जब आप मल्टी थ्रेडेड प्रोसेस की बात करोगे तो आई विल हैव मल्टीपल लाइंस, ये हम बाद में आएंगे. पहले ये अंडरस्टैंड करने की कोशिश करेंगे कि ये लाइन व्हाट डज इट इंडिकेट, एंड सेकेंडली व्हाई दैट लाइन इज ए कर्वी लाइन. एनी आइडिया बॉयज एंड गर्ल्स? क्या कोई बताएगा? डज एनीबॉडी हैव एन आइडिया व्हाट डज दैट लाइन इंडिकेट, एंड मोर ओवर व्हाई इज दैट लाइन इज ए कर्वी लाइन, व्हाई नॉट ए स्ट्रेट लाइन? Varun Bavaskar is saying instruction may have go to statements. So as a result, what? So first, Varun ये बताइएगा, what does that line indicate? That line indicate what? बोलिए. यहां पर मैं लिखूंगा next line पर. The line indicate the flow of execution among the instructions in the code section, in the code or text. मतलब ये हुआ कि for example if I say that this is my code section, let us imagine this is my code section. So let's say this is my code section, code or text. What does this code contain? Let me write. This code contain instructions I1, I2, I3, I4, so on. ये instructions कैसे execute होंगे? How are these instructions going to be executed? सभी को पता है, in a one-human machine, one-human architecture, these instructions are executed purely on sequential basis. These instructions are executed, the flow of execution is purely sequential. मतलब हम पहला फर्स्ट इंस्ट्रक्शन एग्जीक्यूट करेंगे, देखिएगा. I will first execute instruction 1, then I2, then I3, like this. So when I start the execution of the instructions one by one, I1, then I2, then I3, sometime it may happen, listen to me boys and girls carefully. Sometime it may happen that, ऐसा हो सकता है sometime, कि imagine for example this instruction I3 which I am executing, This instruction, if it is, for example, a branch instruction, if it is a branch instruction, follow me carefully. If it is a branch instruction, अगर ये branch instruction हो, सर ये branch instruction क्या हो गए? ये branch instruction हो सकता है, it may be like a go to statement, या फिर branch instruction होता है, हो सकता है, it may be a function call. It may be a function call. So if it is a branch instruction like go to or a function call, if it is a branch instruction like go to or a function call, so you know it, अगर ये go to होगा तो maybe you have to transfer the control from here to some other place. If it is a function call, you have to transfer it to some other place, right? So if I am transferring the control from here, so far sequential था. अभी अगर go to होगा तो control यहाँ पे आएगा. फिर यहाँ पे अगर फिर एक branch हो तो फिर हो सकता है यहाँ पे आएगा. So therefore, if it is a branch or branch instruction like go to or function call, then there is a skip from here to here. आप ये सारे के सारे instructions skip करेंगे और आपका flow of control directly यहाँ पर आएगा. So that curve basically, जो curve जो है, that indicate, okay, Deepan, the curviness or peaks and valleys on this line typically represent how intensively the thread is using the CPU. No, Deepanshu, that is an interesting comment. आपका जो कमेंट है इंटरेस्टिंग है, बट दैट इज नॉट द रीजन फॉर कॉलिंग इट एज कर्वी लाइन. दीपांशु, अप्रिशिएबल, आपने रिस्पॉन्ड किया, बट द कर्व और पीक और वैलीज इज नॉट द इंटेंसिवनेस ऑफ द थ्रेड्स. व्हाट डू यू मीन बाय इंटेंसिव? इंटेंसिव नहीं है. ग्रो टू ब्रांच इंस्ट्रक्शंस, यू आर स्किपिंग द इंस्ट्रक्शन. यहां से लेकर यहां तक आपने स्किप किया क्योंकि आपने कंट्रोल यहां पे ट्रांसफर कर दिया. सो यू स्टार्टेड एग्जीक्यूटिंग लाइक दिस and suddenly there is a branch, फिर कुछ sequential है, फिर there is a branch, फिर sequential, फिर कुछ a branch like this. So this curve indicates essentially a possible branch. It's not like that. Sometimes some people have said ये curve ऐसा, सर अगर आप thread को floor पे डालो तो it will not be a straight line, वो curve में दिखेगा thread. ऐसा नहीं है. Curve is not, the thread is not any physical entity so that it looks like a thread on the floor. No, the curve essentially indicate the possible breaks, the branch that the instructions are taking, or the execution is having some branch. Are you getting my point? That is the reason for showing. हाँ, अगर आप बोलो for example, suppose if you say, sir मेरे प्रोग्राम में कोई भी branch instruction नहीं है, ना ही कोई function call है. If you say like that, then आपका flow of execution, आपका thread कैसे दिखेगा? Purely straight line रहेगा. Then in that case, your thread will be a straight line. If you say, for example, there are no branch instructions, ना ही मेरे कोड में कोई function calls है, absolutely linear flow of control है, तो आपका thread exactly will follow a sequential line like this. So that is the reason for having, that is the meaning of this line, and what is the meaning of the curves. So that is the reason. So बच्चों आप समझ गए होंगे कि every traditional process, every heavyweight process by default is a single threaded process. उसमें thread रहेगा. So thread invariably indicates the order, the flow of execution within the instruction. बस ये है thread. ये है concept of single threaded process. ये है traditional process. अब हमें understand करना है, sir, what is multi-threaded process? जब ये है single threaded process, what is multi-threaded process? And why should we go for multi-threading within a process? Are you getting my point? Why should we go for multi-threading within a process? So what is the motivation? What is the background behind the development of multi-threading within process? Background. Vinay Kaloji, heap is also part of address space. No problem. Heap is also part of address space. It is not shown. I said etc. अगर आप टेक्स्ट बुक देखें तो यहाँ पे they will put dots like this, etc. Other parts. Okay, Varun Bavaskar, that is correct. Thank you for the comment, Varun Bavaskar. Vinay Kaloji, it is part of address space, beta, don't worry. All right. Not shown here, but do you imagine global variables and heap is part of the shared address space of the process. Don't worry. There are many other things which are part of address space not shown in the diagram. So that doesn't mean they are not. All right. Very good. चलिए बच्चों आगे बढ़ेंगे। अब आई एम ट्राइंग टू बेसिकली मेक यू अंडरस्टैंड द आइडियोलॉजी, द मोटिवेशन फॉर मल्टी थ्रेडिंग. So let me write motivation. Motivation for multi-threading. Why multi-threading? There should be how this concept actually came into being. कैसे concept develop हुआ multi-threading का? Motivation, historical perspective आपने understand करना है. So let's understand. So boys and girls, please try to understand and make a note that ट्रेडिशनली बिफोर मल्टी थ्रेडिंग का कॉन्सेप्ट या मल्टी थ्रेडिंग जो आइडियोलॉजी है जो डेवलप हुई है बिफोर मल्टी थ्रेडिंग, हाउ वाज बेसिकली concurrency being done, concurrency in server design or concurrency in applications, how was it done before multi-threading? उसके लिए मैं एक छोटा सा आपको सिनेरियो दूंगा, छोटा सा एग्जांपल दूंगा, so please follow carefully. I'm taking in the case of a typical client server environment, which I'm very sure you are all familiar with. Consider the following client server environment. I have a network or local area network, you can say. These are the clients and there is a big server machine here. This is a server machine. And this server machine is having a huge big hard disk. And maybe this server machine is also having a continuously running process which is generally called the daemon process. And that may be a web server. That may be a web server, imagine. Or maybe it could be a database server. It may be any other such server like that. Any server like this. And boys and girls, let us imagine these are the client machines. These are the client machines, several client machines. Client 1, client 2, client 3, client 4, and so on. So for example, these clients at some point of time, imagine the web server, these clients in the form of web browsers, client machines, web clients, they send a request for accessing the web resources. It may be some web page or some web resource. This is a request queue. We'll call it as request queue. So these requests have come from the several clients. These requests have come, request 1, request 2, so on, some K requests, 100 requests, 200 requests like that. Right? So some K requests have come simultaneously at point of time T. At point of time T. Now these requests may be for some web resource like web page or some other content of the web server. Okay? And now the question is, how are we going to satisfy these requests? What are the different paradigms? What are the different approaches? कौन से different approaches से आप ये request serve कर सकते हो? Initially, concurrency in server design. Before concurrency, these requests were satisfied on a sequential basis, sequential approach. These requests were satisfied in a sequential way, sequential approach. Sequential का मतलब क्या है? Can you please write down in the chat box and let me know? Can you write down in the chat box and let me know what does it mean by satisfying the request on a sequential basis? Come on, boys and girls. I hope you are following my lecture also. In addition to asking your general questions on कैसा आप पेपर कैसा लिखे, आपके कितने मार्क्स आए, right? This discussion is also going on. This discussion can happen in Telegram channels, WhatsApp groups, not in the live lectures. Harshit Jagal, beta, please get in contact with me, connect with me on Telegram channel and seek advice, not in this lecture. हाँ, अगर मैं एक जनरल लेक्चर रखूं, ask me anything, जब आप पूछो क्वेश्चन. जब एक सीरियल डिस्कशन चल रहा है यहाँ पर on a particular topic, I expect that you basically respond to this and respect the lecture. I appreciate that. That's the reason I said that this series will be meaningful only if we have sincerity and seriousness. ठीक है? Otherwise मैं आपके टॉपिक पे जाऊंगा, मैं आपके टॉपिक्स, आपके कमेंट्स पढ़ूंगा, then I will have my distraction. फिर लेक्चर का जो वेरी पर्पस है डिफीट हो जाएगा. हाँ, प्लीज, नो प्रॉब्लम. तो प्लीज आंसर, ट्राई टू फॉलो. ठीक है, देखिए मैं पूछा था हाँ सीक्वेंशियल अप्रोच. सो फर्स्ट अप्रोच इज सीक्वेंशियल. सीक्वेंशियल का मतलब है वन आफ्टर अनदर. मतलब वेब सर्वर क्या करेगा, इट विल टेक द फर्स्ट रिक्वेस्ट, टोटली सेटिस्फाई द रिक्वेस्ट. जब वो कंप्लीट हो जाएगा तभी वो सेकंड रिक्वेस्ट लेगा, देन थर्ड रिक्वेस्ट, देन फोर्थ रिक्वेस्ट. दिस इज हाउ सीक्वेंशियल सर्वर डिजाइन वाज देयर. Many of the client server applications traditionally in the beginning, the client server computing was in the naive stage, initial stages. Server design was following sequential design. This is good as long as the load is less. Agar requests come out, so this is okay. Lekin agar number of requests are more, if the number of requests are more, then traditionally or definitely sequential approach will suffer from the problem of dash. Kya problem hoga? Agar number of requests are more, then sequential approach of serving the request will definitely will have what? Will have the problem of starvation. Starvation. Particularly those requests which are at the end, जो queue में end में हैं, वो definitely they will experience starvation. To overcome the problem of starvation, what was the other approach thought of was concurrent server design. Please follow this because you can see these content which I am telling now, you won't find in any textbook. You won't find it. This I am sharing based on the experiences. So follow this. Concurrent server design. Concurrency, listen to me. Concurrency in server design was first achieved by using the concept of multi-process approach. Multi-process approach. Multi-process approach. Concurrency in server design initially was done by using multi-process approach. मतलब आइडिया दे रहा हूं, फिर उसके बाद क्वेश्चन पूछूंगा. मल्टी-प्रोसेस अप्रोच का कॉन्सेप्ट ये है कि ये मास्टर फाइल सर्वर प्रोसेस या वेब सर्वर प्रोसेस है, वो क्या करेगा? इफ इट ऑब्जर्व दैट देयर आर के रिक्वेस्ट पेंडिंग, देन इट विल स्पॉन. आई एम यूजिंग द वर्ड स्पॉन. स्पॉन मतलब इट विल फोर्क, इट विल क्रिएट, स्पॉन के इंडिपेंडेंट प्रोसेसेस. This is process P1, this is process P2, process P3, process PK. All these processes will be kept in the ready queue and every process will be assigned to serve one request. So this process will be coupled to satisfy this request. Request 2 will be coupled with process 2. Request 3 will be coupled with process 3. Request K will be coupled with process K. हर process को एक individual request दी जाएगी to serve the request, to satisfy the request. Are you getting my point? So this is how concurrency was done. So all these processes are there in the ready queue. और यहाँ पर हम एक scheduling technique like round robin we can use, like round robin. So some time quantum will be given to this process, then another time quantum will be given to this process. So therefore, user will get an experience that concurrently all the processes are getting served, and you know it, round robin is not suffering from the problem of starvation, overcome the problem of starvation. So boys and girls, I am to tell you that initially concurrency in server design was implemented using multi-process approach concept, right? By spawning, creating multiple processes serving independent request. Serving independent request. So boys and girls, I am supposed to tell you that this type of multi-process approach of concurrency existed for quite a long time. For quite a long time. Traditional Unix environment में देखो आप तो this is how multi-process approach से concurrency was achieved in server design. And let me tell you, how do you achieve this concurrency? Through multi-process approach. You know it. How do you create from master process another child process? Using in the mechanism, using the system call by name fork. Fork system call. The matlab, the master file server process or master web server process will fork k child processes. So these child processes are created. These child processes are exact replica of the original web server or file server or database server process. Exact replica, exact copy. You know it. जब आप fork system call से एक child process create करोगे, the child process is an exact replica of parent in terms of address space, in terms of content. Is it not? In terms of content, in terms of address space, the child process will be an exact replica of parent. So if I have 100 process, 100 requests, मतलब हम 100 child processes create करेंगे through fork mechanism, having 100 independent processes with their address spaces in memory. ये है concurrency in server design with multi-process approach. So this type of concurrency existed for quite a long time, लेकिन इसका एक drawback है. Can anybody tell me, those who have studied, can anybody tell me what is the drawback of achieving concurrency in server design with multi-process approach? And that drawback has led to the evolution of multithreading. So what is that? Can anybody tell me? So here I'm writing for your convenience. What is the drawback of achieving concurrency in server design? Through multi-process approach. Using mechanisms like fork system call. Any idea? Yes, functionality of each will be same. That is correct. And it will lead to waste of resources. देखिएगा, जब ये original master file server process है, please follow. This original master file server process या server process बोलेंगे. Server. It has its address space and the thread of control. Now when I use fork system call, और एक इसकी copy होगी with the same address space as a separate copy. Then again it will have another one with a separate copy of address space. So like that, I will have k such processes with an own address space. So this will have its own thread of control. This will have its own thread of control. This will have own thread of control. मतलब ये हुआ कि there will be k copies of address spaces. K copies of address spaces. और जब एड्रेस स्पेस कॉपी होगा, अंडरस्टैंड करने का पॉइंट है, जब एड्रेस स्पेस कॉपी होगा मतलब इंस्ट्रक्शंस कॉपी होंगे यहां पर, ये भी सेम सेट ऑफ इंस्ट्रक्शंस, ये भी वही डुप्लीकेट सेट ऑफ इंस्ट्रक्शन, ये भी डुप्लीकेट सेट ऑफ इंस्ट्रक्शन. जब एड्रेस स्पेस कॉपी होगा, कोड सेक्शन कॉपी होगा हैविंग के कॉपीज, तो मतलब फंक्शनैलिटी सेम होगी. एज विनय कॉलोजी हैज सेड, फंक्शनैलिटी सेम होगी. जब फंक्शनैलिटी सेम होगी, राइट, सो व्हाई शुड आई हैव के कॉपीज ऑफ एड्रेस स्पेसेस? विल द फंक्शनैलिटी, अंडरस्टैंड कीजिए, हाँ, अगर सबकी फंक्शनैलिटी अलग अलग होती, तो देयर इज अ मीनिंग ऑफ हैविंग के कॉपीज ऑफ एड्रेस स्पेस. बट व्हेन के कॉपीज ऑफ सबकी फंक्शनैलिटी सेम ही हो, बिकॉज कोड सेक्शन सेम है तो फंक्शनैलिटी सेम होगी. जब सबकी फंक्शनैलिटी सेम ही हो, तो व्हाट इज द फन इन हैविंग के कॉपीज ऑफ एड्रेस स्पेस? मतलब लॉजिकली, नेचुरली हमें यह होना चाहिए, हमें ऐसा होना चाहिए कि सिर्फ एक कॉपी ऑफ एड्रेस स्पेस हो एंड मल्टीपल प्रोसेसेस शुड बी एग्जिस्टिंग. These are multiple process. So if I have that architecture के एक ही copy of address space हो और multiple processes of execution हो within that address space, then definitely I am going to achieve a lot of benefits. First obvious benefit जो मुझे मिलेगा वो है resource sharing, economical, cost effective, ये मुझे benefit मिलेगा. Why should I waste my memory, which is a very important resource, with having k copies of address space? If I have only one copy of address space, I will optimize memory. I will basically reduce the memory requirement and other resource consumption. That is a main advantage, main benefit of multi-threading. So main reason for achieving multi-threading is resource sharing, economical design, by way of having one copy of address space shared by all those independent processes. जो हम independent processes बोलेंगे, हम उसे बोलेंगे threads. A process having multiple threads, having share of only one copy of address space, that is the ideology of multi-threading. So this concept, this research has given rise to the philosophy, the paradigm of multi-threading, right? So that is the second type of achieving concurrency. So concurrency in server design, see on board. Concurrency in server design, the second approach was done by using multi-threading with multi-threaded process. Concurrency in server design was basically meant by multi-threading. Abhishek Rajput is asking a very fundamental question. Starvation का मतलब क्या है? स्टारवेशन का मतलब हो सकता यह है कि शायद आप कंप्यूटर साइंस के स्टूडेंट ना हो, या शायद आप फर्स्ट ईयर के स्टूडेंट हो या सेकेंड ईयर के स्टूडेंट हो और आपने ऑपरेटिंग सिस्टम पढ़ा ही ना हो बिल्कुल, राइट? somebody may respond to Abhishek Rajput, what does starvation mean? ठीक है, तो चलिए, so this was the basic objective, the background behind the development of multi-threaded process. तो मतलब conceptually अगर आप समझो, suppose if I say this is my process multi-threading is basically, or multi-threaded process is indicated, I'm going to show by means of a simple diagram. Please see on board. So this is a single threaded process, and this is a multi-threaded process. Multiple threads are active. So I will call this as thread 1, thread 2, thread 3. The difference is that, or the concept is that all these threads will share only one address space rather than having n copies or k copies of address spaces. That is the basic idea, that is the basic advantage. So this is how a multi-threaded process would look like, and this is my, so therefore I will write here, this is single threaded process and this is multi-threaded process. Single threaded process and multi-threaded process. अब यहाँ क्वेश्चन ये आएगा कि सर के multi-threading is it only applicable at server side? क्या सर्वर साइड पर ही एप्लीकेशन होगी, अप्लाई होगा? क्या क्लाइंट साइड पर भी multi-threading पॉसिबल है? एंड इसी तरह क्या इंडिपेंडेंट एप्लीकेशंस पर भी multi-threading पॉसिबल है? इसका आंसर है हाँ, यस. Multi-threading is applicable. Let me write down as a note for you so that it will be helpful for you. So here I say multi-threading, the concept of multi-threading logically applies at server side. However, in some applications, it is even applicable. It is even applicable at client side and also in independent applications. Independent का मतलब standalone applications. जैसे कि अगर आप जो हम एग्जांपल देखे थे सर्वर साइड, I mean web server was there implemented as a multi-process approach concurrency. Now if I go for multi-threaded approach, then the diagram may look something like this. Look at this. Multi-thread server architecture. This is how it will look like. The client will send the request. ये आपका master file, master server process है. This is the master server process. So what will it do? Earlier it was creating a process. अब वो process create नहीं करेगा. Second step, it will create new thread to service this request. So new thread is created. So this will service the request. After some time another request comes. Then again it will create another thread. Request 1. Then now request 2 will be served. After some time another request comes. Right? It will create another thread. And it will serve request 3. So like that, multi-threaded server can be implemented. Multi-threaded server can be implemented with this type of architecture. So एक तो natural ये है कि you can apply multi-threading at the server side. This is very natural. Multi-threading can also be applied at client side. It can be applicable at client side. Sir, can you give some example? Let me ask. Multi-threading is also applicable at client side. Let me see who will answer. Let me see whether you are knowledgeable or not. Server के लिए तो बहुत आसान है understanding. Server is meant for servicing the request. So when multiple requests come, I can create multiple threads and serve the request. लेकिन in some scenarios, कुछ ऐसे scenarios है जहां पर client side भी multi-threading is meaningful. Let me see who is knowledgeable. कि can you suggest an example? क्या आप कोई example बता सकते हो जिसमें client application भी multi-threaded हो सकता है? Oh my God. Ashutosh Sharma is asking a question. Sir, OS के prerequisites क्या है? Start करने से पहले मतलब. This is the problem. That's why I don't prefer to take classes on YouTube. Because there are a variety of type of students, lot of disturbance, lot of variation, right? No sincerity, no seriousness. That's the reason I get discouraged from taking classes on YouTube. People just walk in and walk out as they wish, like a garden. Am I right? No, not sorry. Sorry is not the answer for anything. You understand? देखिए एक सीरीज लेक्चर है ये. If I would have put the topic like ask me anything, आप पूछ सकते हो. बेटा एक सीरियस डिस्कशन चल रहा है, आप उसमें क्वेश्चन पूछ रहे हो which is not at all relevant to the topic, तो फिर the purpose of taking this session is defeated. Is it not? You tell me, suppose if you are at my place, क्या होगा? Am I right or wrong? ये बोलिए आप. आप लेक्चर ले रहे हो, आपके भी कोई स्टूडेंट ऐसे ही अगर पूछेगा तो फिर क्या मतलब होगा? टॉपिक का क्या मतलब है? And then whenever we are taking any general session, whenever we are taking orientation session, जैसा कि पिछले orientation session में so many people are flashing messages. Sir, please continue Naya Agaaz series. Sir, please continue the lectures. And when I take the session, this is what is going to happen. Seriousness should be there. Sincerity should be there. Then only the purpose is meaningful. और मेरा भी फिर motivation रहेगा, right? Okay, Vinay Kaloji, multi-threading can be done using Java, but you are not getting an example. ठीक है, मैं example बताऊंगा, सुनिएगा. The example of client-side multi-threaded application is web browser. Web browser. Web client. Web browser is also called web client. Now, do you get an idea, Vinay? Do you get an idea how web browser or web client can be multi-threaded? देखिए वेब सर्वर तो मल्टी थ्रेडेड मीनिंगफुल है, लॉजिकल है. क्या क्लाइंट वेब ब्राउजर भी मल्टी थ्रेडेड हो सकता है? तो कैसे मल्टी थ्रेडिंग होगी वेब क्लाइंट में? दिस इज योर ब्राउजर फॉर एग्जांपल. दिस इज योर ब्राउजर. लेट्स से दिस इज योर ब्राउजर. दिस इज एड्रेस बार वेयर यू आर गोइंग टू टाइप द URL. राइट, दिस एड्रेस बार यू टाइप समथिंग www.abc.com. something like this. बोलिए, how can this browser be multi-threaded? Any idea? See, the web page that you are trying to download, the web page जो abc.com website है, उसका जो web page आप download कर रहे हो, the web page may contain different type of content. हो सकता है you can have static text here. It can have some dynamic content. It can have some multimedia content. Multimedia. Correct? Some audio, some video, it can have some advertisement, etc. So it's quite possible that this content may be coming from different sources. This may be coming from one source, this may be coming from another source, this may be coming from another source. Quite possible. तो अगर मेरा ब्राउजर सिंगल थ्रेडेड डिजाइन होगा, then it will not have too much responsiveness, much interactiveness, because पहला आपका थ्रेड ये डाउनलोड करेगा, फिर वही थ्रेड ये डाउनलोड करेगा, फिर वही थ्रेड ये डाउनलोड करेगा. उसके बजाय इफ यू मेक ऑल दिस कंटेंट एज मल्टी थ्रेडेड, मतलब यू डिजाइन दिस एज थ्रेड 1, यू टेक दिस एज थ्रेड 2, यू टेक दिस एज थ्रेड 3, then my browser will become multi-threaded server, multi-threaded client, a multi-threaded browser. So this example illustrates that some applications like web clients can also be multi-threaded. So multi-threading is not limited or confined to server side, it is also meaningful and applicable at client side. ये दो चीजें हो गई. फिर थर्ड पॉइंट मैंने कहा मेरी पिछले स्लाइड में, if you remember, multi-threading is not just applicable here. Multi-threading is also applicable at client side. So this is an example. Previously मैंने कहा is also applicable in independent or standalone applications. Standalone applications में भी multi-threading applicable है, not just client server. Standalone applications में multi-threading is meaningful. Can you give an example? Think of an example, Vinay, or other people who are present in the class and who are seriously listening to me. Can you think of some application which is a standalone application and having multi-threading in it? Multi-threaded standalone application. Hint ये दे रहा हूं कि सभी को आंसर पता है, आपने just recollect करना है from your usage and tell me what is the standalone popular application which is multi-threaded. Any idea? Standalone application which is multi-threaded. Come on, boys and girls. I'm saying that everybody knows it, except that perhaps you don't know that, yes, it is multi-threaded. But when I try to explain, then hopefully I'm sure you would appreciate, you would recognize that, yes, it is multi-threaded. The very popular example of standalone application which is multi-threaded is our popular Microsoft Word. Microsoft Word. Microsoft Word application. Can you tell me how is it multi-threaded? So the traditional Microsoft Word as a process can have one thread for editing, one thread active for editing, right? Another thread active for spell check. स्पेल चेक आपने और किया होगा जब आप माइक्रोसॉफ्ट वर्ड में कुछ कंटेंट टाइप कर रहे हो तो while you are typing, if there is any typo error, spelling check error, automatically वो underline करेगा with red ink. So that is being done by a separate thread attached to the main application as a spell check application. So spell check is getting connected to the Microsoft Word as a separate thread, as a thread within it, right? So this is how we can. Maybe if you want tomorrow, you can have some graphics content here as a thread for graphics content. मतलब जैसा कि आप आपके cell phones में when you are typing on WhatsApp, when you type some word, immediately it will suggest some graphical symbol. So like that in Word also you can incorporate it graphics. So a standalone application can also be multi-threaded. So boys and girls, I am to tell you that multi-threading is not limited at the server side. It can also be at the client side, and it can also be for standalone applications. So this is the basic idea, basic concept of threads and multi-threading. Basic idea, basic concept. Then we have to study what are the other benefits of multi-threading. What are the other benefits? So let's try to see from the slides some of the important points which I have got it here for you. So let's read one by one to build up understanding. So first point number one, which I am supposed to tell you, most of the modern applications are multi-threaded, be it client side, be it server side, be it as standalone applications. Threads run within application, within process. So thread is not an independent unit. देखिएगा बच्चों, from program you create a process. So there is no existence of process without a program. उसी तरह there is no existence of thread without process. Process के अंदर ही thread होगा. Thread का कोई independent existence नहीं है. Don't think that thread is a separate thing. No, it is existing within the process. It is part of process. So threads run within application. So I can have multiple threads here like this. Multiple tasks within the application can be implemented by separate threads. That's what I say. Like update the display, fetch the data, spell checking, answer a network request. So all these can be done within a single task. Chrome standalone application. Yes, Chrome is a standalone application, but it is a browser. It is a browser, is it not? Chrome is a browser. It's not standalone. Generally use Chrome for basically communicating with the web server. Am I right, Rohit? So the other point which I am supposed to tell here, process creation is heavyweight. सुनिएगा, process creation is heavyweight, while thread creation is lightweight. हमें अंडरस्टैंड करना होगा कि why thread is known as lightweight. Traditional process is heavyweight क्योंकि उसका अपना पूरा address space है. Thread is lightweight. There are two reasons for calling thread as lightweight. Number one reason for calling thread as lightweight is because it is sharing address space of the process. मतलब हर एक थ्रेड का अपना ओन इंडिपेंडेंट एड्रेस स्पेस नहीं है. थ्रेड स्पेसिफिक डेटा जो होगा वो बिल्कुल लाइट होगा, बहुत छोटा होगा, बहुत स्मॉल होगा. सो therefore thread is lightweight process for the reason that it is sharing common address space and each thread has a very light content, less information independently associated with it. That is one reason. Second reason और एक है, मैं आपको थोड़ी देर में बताऊंगा why it is called lightweight. Threads can simplify code and increase efficiency. And because of the benefits of multi-threading, even most of the operating system kernels have also gone for threading within the kernel, within the operating system kernel. And such kernels which are multi-threaded are known as multi-threaded kernels. So kernels are also generally multi-threaded. So that is the point. So this is how my multi-threaded process would look like. Can you have look at the structure of the thread, please, within the process? So traditionally, in the form of a block diagram, you can show thread traditionally like this. This is my process, an equivalent of this, and threads are active here. Something happened. So again, I will redraw. Why this line is coming? Anyway, no problem. I don't know what is happening. So within this, अच्छा फ्लो चार्ट सेलेक्ट करना पड़ेगा. This is okay now. So within this I have multiple threads of control, 3 threads. So this is my multi-threaded process. Multi-threaded process T1, T2, T3. Look at this. Look at this. I have common address space. This address space is common. Shared address space. Shared address space. That means I will have only one copy of code section, one copy of data section, one set of resources. This includes heap also. This includes other resources also. Heap, other resources, global variables, etc. लेकिन जो भी content, जो भी information should have independent with every thread, should have thread specific data, thread specific information. So what is that? No two threads can have same set of registers. So I will have separate copy of registers. No two thread can have the same stack क्योंकि हर thread अपना own execution follow करेगा code section में. कोई thread एक function call करेगा, कोई दूसरा thread कोई दूसरा function call करेगा, तीसरा thread कुछ और function call करेगा. So every thread should have its own stack. Every thread will have its own program counter. This is called thread specific. मतलब हर thread के अपना own set of registers होगा, own program counter होगा, own stack होगा. No two threads can share the stack. Every thread will have its own stack. Every thread will have its own set of registers, and every thread will have its own program counter. So this is one independent thread. This is another independent thread, another independent thread. So thread independent data जो है, that is limited to that. That is light. This is less information than in comparison to the process. Those attributes which are there for the threads will be kept in its table called TCB. जैसा process control block है, यहाँ thread control block होगा. Thread control block will contain the attributes of the thread like thread state, thread ID, thread priority, thread program counter value, thread यहाँ पर thread control block. इसी तरह this thread will also have its own thread control block. This thread will also have its own thread control block. Then the common attributes perhaps of the process will be there in your regular PCB. And this itself will become the reason for calling, one of the reasons for calling thread as lightweight process. Listen to me. Generally, the volume of information kept in TCB, thread control block, is lesser than the volume of information kept in PCB. Again, I repeat. Generally, the volume of information जो TCB में होगा, thread control block में होगा, that is lesser than the volume of information kept in PCB. तो जितना content of control block छोटा होगा, कम होगा, उतना ही context switching में fast होगा. The thread control block content is less than the content information in PCB. So therefore, when I switch from when I perform a context switch from one thread to another thread, I will have to save less information, load less information. Matlab, thread switching is super fast, faster than process switching. This is also one of the reasons for calling thread as lightweight. I can switch from one thread to another thread very fast, having less information to be saved and loaded. That is another reason for calling thread as lightweight process. So there are two reasons for calling thread as lightweight process. Each thread share the common address space. Each thread will have less thread specific data. So that is one reason. Second reason is the content of TCB is lesser than the content of PCB. This will facilitate faster context switching, less context switch overhead, and therefore it is known as lightweight process. So this is the basic ideology, the concept of thread as a process. ठीक है. So this is all what we have, and here you will have the benefits of threads. So we are going to see what are the relative benefits. हमने सबसे पहले कहा resource sharing. One of the primary reason for having threads is basically to share the address space. Resource sharing. Threads share resources of process easier than shared memory or message passing, which are IPC mechanisms. So आपको kernel space से use करना पड़ेगा. So therefore, they are basically difficult. So because of resource sharing, this become economical or cost effective. Cheaper than process creation, thread switching, lower overhead than context switching. अभी मैंने कहा था. Thread switching from one thread to another thread takes less time, less overhead. And less overhead कम होगा तो efficiency बढ़ेगी. So it will lead to efficiency of the system. Moreover, thread switching will also impact the scalability. Processes can take advantage of multi-core architectures. ये भी एक काफी ज्यादा important benefit है multi-threading का. काफी ज्यादा important benefit है multi-threading का. आज के जो processors है, modern processors है, you know it very well. They are multi-core. You say i3, i5, i7, i3 processor, i5 processor, i5, i7 processor. मतलब if I take i3 processor का मतलब यह है कि it has 3 cores. One core is almost equivalent to, you can say, like a processor. ठीक है? Say for example, this is my 3-core CPU. If this is my 3-core CPU, so listen to me. If this is my 3-core CPU, let me draw with a different ink. So this is core 1, this core 2, and the other is core 3. So this is your i3 CPU. Core 1, core 2, core 3. Core 1, core 2, core 3. One core is almost equivalent to one CPU. Traditionally works like a CPU. You can achieve that functionality of CPU with one core. If I have 3-core processor और मेरा अगर आपका application single threaded process है, तो आप मल्टी कोर की जो पोटेंशियलिटी है आप एक्सप्लॉइट नहीं कर सकते, मल्टी कोर का आप एक्सप्लॉइटेशन नहीं कर सकते, बिकॉज एक थ्रेड एक कोर पर रन करेगा, बाकी के 2 कोर्स आइडल रहेंगे. सो यू कैन नॉट फुल्ली यूटिलाइज द कैपेबिलिटी ऑफ ए मल्टी प्रोसेसर, अ मल्टी कोर प्रोसेसर. तो मल्टी थ्रेडेड एप्लीकेशंस कैन एक्सप्लॉइट मल्टी कोर आर्किटेक्चर्स. दैट इज व्हाट इज स्केलेबिलिटी पैरामीटर. मतलब इफ माय प्रोसेस हैज मल्टीपल थ्रेड्स, लेट्स से देयर आर 3 थ्रेड्स, then I can schedule one thread here on core 1, schedule another thread on core 2, schedule another thread on core 3, and I can achieve real parallelism or real concurrency. So that is another important benefit of multi-core. They can exploit, they can utilize the multi-core architectures or multi-core CPUs and scale the application, make the computation faster, computational speed up हो जाएगा आपका, efficiency बढ़ेगी आपकी. So because of this reason, most of the modern applications are multi-threaded. Client, server, standalone applications, they are multi-threaded. So that is the relative merits of multi-threading. So as a drawback तो ऐसे कोई नहीं है. So that ends with basically one topic of multi-threading or threads. That is where we have seen what is the concept of thread, what is the ideology of thread, what is the background behind multi-threading, why multi-threading basically is needed. And then we have seen the architecture of multi-threaded process, and then finally we have seen the benefits of typical multi-threading and types of multi-threading, in the sense that multi-threading is applicable at client side, server side, and even for standalone applications. इसका बाकी का जो top part है for multi-threading, then we have to study about like multi-core programming, where we can achieve parallelism and concurrency, where we need to understand what is the difference between parallelism and concurrency with regard to multi-core programming. And the last topic would be on types of threads, like we have user level threads and kernel level threads. So that we will see in another session, because the intention of this session is to take for 60 minutes and not more than that. ठीक है, next session जब भी plan होगा, we will continue and complete the other part of thread applications, that the multi-threading. And then if time permits in that session, I will also take up some case study on fork system call, because before multi-threading, fork was the approach of achieving concurrency in process design or server design. So next class में हम देखेंगे with regard to that. Till that time, thank you so much. Take care and continue your preparation. Right? Thank you. Good night.